All right. Today I'm going to talk about queen rearing and queen biology, but I'm going to start with a PowerPoint on comparing different lines of varroa-resistant bees. So as it says here, I believe that varroa-resistant bees are the foundation of honeybee health. And the other foundation, I guess you could say, is good management. So why should you care about having varroa-resistant stock? So many of you know that what's called the varroa virus complex is the most destructive thing to honeybee health. And chemical treatments are not always able to save your bees. So you could treat with chemical treatments, or you could use other systems of management, and you still may have a major varroa problem, which can, if not addressed, result in the death of a colony. So varroa mites transmit or vector about 20 different kinds of viruses, and both the mite feeding, sucking, or feeding on the pupae, and the viruses themselves reduce the immune system or reduce the immune effect of the honeybees. So it makes it harder for them to resist other pathogens like nosema, the pathogen that causes European foul brood, and other viruses. So varroa populations double about every month between starting with April into August. And by June or so, the percent of pupae that are parasitized by mites has increased rapidly. And by September, October, a much larger percentage of the bees that are emerging as adult bees from pupal cell are have been parasitized by varroa and have been challenged by viruses that the varroa have transmitted to them while feeding on them. And non-resistant colonies, which aren't treated, almost always fail to survive the winter. And it turns out that unfortunately most hobbyists continue not to treat for varroa, and the vast majority also do not monitor varroa mite numbers and are ignorant of what's going on in terms of varroa in their colonies. So by the time you see the picture of the bee on the right, on my right, which has got shriveled up wings, that's a deformed wing virus that causes that. By the time you see a number of those, a small number, but you just start noticing them, more than just one or two, or if you see something on my left, which are the drone pupae that have been exposed, and you see the red dots, which are adult varroa on them, at that point, your colony, that colony that has one or the other of those situations, has one foot in the grave. So a number of beekeepers treat several times at least. Commercial beekeepers may treat 5 or 6 times during the season. Hobbyists sometimes will treat several times. Even a treatment relatively late, if you treat several times, the last treatment, let's say, is in August, that can't guard against what are called now varroa bombs. These are colonies that are collapsing due to varroa and the viruses that they transmit. And those colonies, as they collapse, are being robbed out. Their honey stores are being robbed by strong, healthy colonies. Those colonies are bringing back varroa mites with them, along with the honey that they've robbed. And those that lack resistance, even if they have been treated several times during that growing season, are basically sitting ducks if they're bringing those mites home with them from a collapsing colony. And under those circumstances, if that colony lacks any resistance, it cannot respond at all. The only thing that might save it under this kind of example is if the beekeeper, she or he, samples again, monitors for varroa, discovers they have a big problem, and then they apply some kind of treatment. But generally, beekeepers don't treat after August or September. So this talk is going to focus on 3 different varroa-resistant honeybee lines. And the first 2 I'm going to talk about are the varroa-sensitive hygiene line, or VSH. And the second one is the PAW line, which was derived from the VSH line. So VSH honeybees mated with commercial Italian bees were used to produce the PAW line. So what is VSH behavior? What is varroa-sensitive hygiene behavior? Well, this means that through the wax cap, bees that have this trait can detect that there are varroa feeding and reproducing on the pupae underneath the wax cap. What they normally do then is they uncap that cell, they remove the pupa, and in doing so, they destroy the immature mites, which are quite delicate, sort of like soft shell crabs or crayfish. So here's a diagram, again on my left, showing a worker bee, a house bee. The cell is uncapped with that cell that's at the lower part of the diagram, and the house bee is removing the pupa by just tearing it apart, by dismembering it, so bit by bit. And in doing so, again, it destroys the immature mites. On the right is a photo from one of my colonies that shows some pupae sort of a little bit above center in that photo that are now partial pupae. And I've got a little indication, there's a little arrow. I don't know how visible that arrow is that I added to point to them, but again, a little bit above center. So that's an indication that you've got bees performing varroa-sensitive hygiene or expressing varroa-sensitive hygiene. So what's the net result of this varroa-sensitive hygiene behavior? Well, each time that these bees that possess this behavior disrupt the reproductive cycle of a mite, she usually escapes. The adult female mite, the mama mite if you will, usually escapes unharmed, but she produces 0 offspring. So over time, and replicated by many mites and many more bees, the result is preventing a major buildup of varroa mites in that colony. Destruction of those pupae that have been parasitized and have received viruses as a result from the varroa feeding on them also reduces the chance of viruses being able to infect the entire colony. So colonies headed by VSH or PAW line bees, PAW line queens, are quite effective at keeping varroa populations low. There have been a number of studies showing this, including studies under commercial beekeeping operations with both those lines. The VSH trait, we're going to talk about genetics now a little bit. The VSH trait is inherited in what's called an additive manner. And as a result, the pure VSH queen mated with non-resistant drones that do not possess resistance to varroa, still give good control of mite populations. You get even better results if on the drone side you have a number of drones, a percentage of drones that also are carrying that VSH trait. They themselves ideally are sons, of pure VSH queens. So if you want varroa-resistant queens, and you really should, then make sure they were produced from a queen that has been instrumentally inseminated, which is basically a form of artificial insemination, so that the genetics the genetics are known, and they're known to be genetics of either VSH or PAW line. On the other hand, colonies that are headed by a queen that herself is the daughter of a pure queen, but that queen has open mated with non-resistant stock, those colonies do not exhibit resistance. So if you plan to raise queens whose colonies will express VSH, then you need to buy, again, instrumentally inseminated VSH queens from John Harbaugh or Pauline queens from VP Queens. VP also sells, they sell a couple of lines of their own that have VSH in them. There are no data that I'm aware of that have been publicly made available to show how effective these lines are. So I would stick with Pauline if you're going to buy from VSH. So what about the third varroa-resistant line? That's the Indiana mite biter line, which was developed at Purdue University. In this case, these bees remove mites by grooming them off them, and it's not that common for bees to be able to groom mites off themselves. In other cases, they may groom the mite off a sister bee, and then they often bite the mites, usually the legs, and sometimes the exoskeleton, or what you could call the shell of the mite, often resulting in dead mites. There's a photo here. I'm not quite entirely clear, but it looks like at the front of the mite there's some damaged legs or equivalent of antennae, but also apparently in the middle of the mite it looks like they actually made a tear in the exoskeleton. And on the left, my left of course, is an example of sticky board, which is how you measure how many mites have been damaged. So you have to collect the mites on the sticky board and then under a microscope examine what percent have been damaged to see if you have good mite biter, strong mite biter behavior in that colony. So pure mite biter colonies show reductions, significant reductions in mite populations, and they also show high rates of damaged mites on the sticky boards. And I think it's really good to have this second kind of defense against varroa mites, because for one thing, one example is they might adopt, that is the varroa mites might adapt to VSH behavior somehow and are able to fool the bees, and so they can't find them. So then here's a second means of defense. But unlike or varroa-sensitive hygiene behavior, the mite biting trait is inherited in a recessive manner, as near as I can tell. Now this, when I say near as I can tell, this is based on talking briefly on 2 occasions to Greg Hunt, who was, for want of a better term, call him the father of the of the mite biter line, who started it, and there were other people involved as well, obviously. So what this means practically, when this trait is inherited in a recessive manner, is that at least 50% of the drones should be carrying that mite biter trait, and therefore should really be the sons of pure mite biter queens which have been instrumentally inseminated. So as a result, it's going to take a lot longer to get good control of mites or good expression of varroa resistance if you start with this line. It's going to take at least 3 to 5 years, much more so than if you started with VSH or Pauline, to be able to produce queens that have whose colonies show good effectiveness at reducing mite populations, let's say down to the threshold level, economic threshold level of 1 to 3, depending on who you believe, 1 to 3 per 100 bees. And this assumes that you have good influence over the drone population, which is not that easy, and depending on how many beekeepers you have around you, that can be rather difficult. So the mite biting behavior is a good trait for producing varroa-resistant bees. I would suggest that you start, if you're interested in producing varroa-resistant stock for yourself or for sale or both, with colonies that possess a varroa-sensitive hygiene behavior. So, or I should say queens that possess it. So again, queens that are instrumentally inseminated of either VSH or Pauline stock. And so after several years at least of raising these queens of one or both lines, then I would consider introducing the mite biter trait into your stock. And this will, among other things, increase the diversity of your stock and introduce, as I said before, a valuable new trait against Varroa. So additional reasons for introducing the mite biters into the mix would be that Varroa, or rather the mite biters, are a northern bee. They were developed in Indiana at about the latitude of Bloomington Normal. They've been developed over 10 years from stock, originally stock, Indiana stock, which obviously had a lot of commercial mix in it, but then they've been selected for 10 years in that location at West Lafayette. And they do possess also some Russian and New World Carniolan genetics as well. So to wind this up, I'll use myself as an example, or my bees, I should say. So I have a number of colonies that are headed by pure mite biter queens raised from instrumentally inseminated mite biter breeder queen. And these colonies are able to manage mite levels at or below 2 mites per 100 bees, which is quite good. That's no guarantee that under different circumstances they may be able to do anything like that. There's some evidence that that Varroa resistance seems to change if the bees are put into a very different environment. I think, however, that the resistance that I see evidence of is largely due to the fact that since about 2010 I've been raising VSH queens, and I think it's the genetics from the VSH that are largely responsible for the Varroa resistance I see in almost all my colonies. So I think I feel confident that those of you that are interested in producing Varroa resistant stock would be at least as successful if you start again with Pauline or VSH queens, and then after a period, if you decide, if you're getting good results, you may want to introduce something like the mite biters. And other individuals, including the Gerberdings and Craig Schultz, in the Springfield area have been at least as successful as I have. Are there any questions? A question came up during the break I want to answer, and that question basically was, I'm going to rephrase it, does incorporating VSH behavior, either Pauline or VSH, the VSH original line, does that reduce honey production? There haven't been a lot of studies of that, but the most comprehensive one occurred over a 3-year period. And what they found was basically, this was by Robert Danka and a number of other investigators, including Jeff Harris. And those are personnel primarily or entirely from the honeybee lab in Baton Rouge. What they found was that, first of all, they compared VSH and Pauline headed colonies to the commercial Italian cross that was being used by, or not a cross, but the commercial Italian line that was being used by 3 different producers, honey producers. So producer A had his or her own line, producer B, et cetera, down to C. What they found in general was there was not appreciable difference in honey production at all between the 3 lines. Now the VSH and the Pauline had been outcrossed to the stock that given commercial producer was using. These are commercial Italians that have been largely selected for honey production, and for which usually also means that the really rapid growth rate, high production of eggs and therefore of bees. So they found no appreciable difference. It depended on the year, depended on the investigator. It wasn't, a clear across the board in every case. And they found better survival. These VSH and Pauline colonies were not treated In some cases, the commercial Italian colonies were treated, in other cases they were not. So it was a little bit complex with the 3 different operations. But I would say in general, there's not good evidence that you get a decrease in honey production by outcrossing your VSH or your Pauline. The Pauline was already developed as an Italian type productive line that incorporated VSH, so that's a little less of a surprise. Anyway, I hope that answers your question to some extent.